The European Space Agency, together with Airbus Space and Defense, are set to make history with the lunar-Earth flyby today on August 19 and August 20, so tomorrow, 2024. With this maneuver, which is a double gravity assist, will slow down the JUICE spacecraft, altering its trajectory for a journey to Venus and then Jupiter, its final destination. Welcome back on the Space Info podcast. Here we talk about space and everything related to it. If you are passionate about space, astronomy, technology and everything about it, you can join all our social platforms at the Space Info Club or our website at www.spaceinfo.club, where tons of content and a community of experts are there waiting for you. This is the Space Info Club. Welcome back on the Space Info podcast and on the Space Info channel. So today we talk about JUICE, which is the European Space Agency Jupiter Icy Moons Explorer, a spacecraft unmanned for sure, whose final destination is Jupiter, and particularly its Icy Moons. Three of them I'll reveal, but I know that you already know which of them are. I'll talk about them a little bit later. So let's talk about the presentation. Well, and in particular the event which is going to occur between today and tomorrow. So as said into the introduction, August 2024, 19 and 20. So this is when the flyby with Earth and our natural satellite, which is the Moon. I hope that you know this will occur. So what is a gravity assist and why is it important? Well, this maneuver is critical for JUICE to align its path toward Jupiter, which is the final destination of the mission, enabling the spacecraft to reach the correct orbit. So precise navigation is crucial, as any error during this flyby could jeopardize the whole mission. Indeed, it is a very delicate operation. You have to imagine that you are traveling into space with an unmanned spacecraft with limited input from the external, which is the ground control. So you are in a completely, I would use the word completely 3D environment. But what do I mean? Well, we are used to walk on our planet as human beings, or maybe we are used to drive our car, or we are used to fly a plane, maybe some of us. So if you are flying, you're quite close to this experience, but not so close, because aerodynamics and gravity are, particularly gravity, are affecting our common experience of how a 3D world actually works. Well, in space things don't work differently, for sure. The laws of physics are the same, but you have to think that this spacecraft is like a very little ball flying around a much bigger one, which is a planet in this case, and the flyby will use the gravitational attraction of this planet with respect to the spacecraft in order to modify its trajectory. And it is like you are using an external energy with respect to the spacecraft in order to modify the trajectory. And this modification of trajectory can happen in the 3 dimensions. So let's think about a plane table, and you are running your little ball on that plane. Then an external forces brings this ball towards in a completely different direction, modifying the trajectory. This is something like that happens with the gravity assist, and this is one of the characteristics and one of the reasons why they are so important. And well, they are also important. Well, this is the effect of the gravity assist, so a modification in the trajectory. But why do we still and we want to use gravity assist into a mission? Well, this won't be the first. This is not the first, and it won't be for sure the last gravity assist in the history of unmanned and also manned space missions. Well, they're very important because they allow the spacecraft to save a lot of propellant on board. Well, you actually are not using, if not for very slight and minor correction of your trajectory, you are not using any kind of propellant, but you are using, let's say, the natural gravitational force of an external item, in this case the Earth or the Moon or both, which influence the trajectory of your spacecraft and modify it in the way that you hope, I would say, or a better word would be that you calculated in order to reorient the trajectory of the spacecraft towards a final destination or an intermediate one. For example, in this case, the spacecraft won't be directed directly towards Jupiter, but will face some other minor corrections, some other flybys, because I want to remember to you that the let's say the arrival date, we will see more in detail later, it's around 2030, so we still have something like 6 years of flight into deep space before reaching the final destination. So answer to this question: why is flyby important? For two reasons. Because it's critical, you need a lot of precision. The input condition, the way you face and you inject the spacecraft into the flyby will affect a lot, will completely affect the way it will come out of this maneuver, and so the final trajectory out of the flyby. Second reason, to save propellant. So you can save a lot of propellant thanks to the flyby, because basically you are using no propellant, but you're using the gravitational attraction of an external item, which is a planet or satellite or something. And when I say satellite, I mean for sure natural satellites like our moon. So just some details about the mission, JUICE mission. JUICE spacecraft will travel approximately something like 600 million kilometers to reach Jupiter in 8 years. So, as I was saying, it was launched 1 year ago, 2023. I remember to you that you can also subscribe to this channel or visit our website, where you can find all the material and the information of the launch of the mission and some other details. And I would like to underline that we'll keep publishing details about the mission, so if you want to stay updated, just follow us or subscribe for free to our website and our socials. So in 2030, 2031 approximately, the spacecraft will reach its final destination. So the mission will include gravity assist from Earth, like in this case, then from Mars and also Venus to gain speed. Well, I don't remember the precise order and how many times the spacecraft will fly by with respect to this planet. Don't forget that the center of the orbit, especially at the beginning, but also the center of the orbit is always a point between the final destination and the Sun, which is the major gravity, let's say, actor in the whole mission, which is 99% and something more of the whole mass of the solar system. So that's for sure very important for the gravitational attraction of the whole system. And so multiple flybys, but the dynamics of the thing will be very similar to this one. So some insights. Well, the first 2.5 years at Jupiter will involve about 30 flybys of Ganymede, Callisto and Europa. So which is the difference between these flybys, which are the main topic of today's video, and the one which will occur between today and tomorrow around Earth and the Moon? Well, today's flyby will be used to save propellant and to reach the final destination, so to orient the spacecraft with its trajectory towards Jupiter and its moons. The flybys that you are seeing here will be used to better observe and capture details of Jupiter's moon. So they are basically the same thing. The physics around the flyby is the very same, no difference, but the scope of the flybys will be different. So in that case, I haven't studied yet precisely the physics of those flybys, so I don't have yet the orbital parameters and much more details about those flybys. But and I also think that some correction will be anyway performed by mission control. But those flybys in the future will be used to keep the spacecraft as close as possible or in the optimal trajectory with respect to what scientists need. So maybe you need some precise inclination with respect to the surface, some distance from the surface, or some precise orbital parameters. Again, you use the flybys instead of, let's say, pure propellant to correct the spacecraft and to optimize the whole mission. Don't forget that the amount of propellant is limited, so any kind of correction, think about this. When you are in space, both accelerating and braking with respect to some reference point are expressed in terms of propellant. So when you're driving, you push on your throttle and you spend propellant from your car, and then when you brake, you push on the brake, but no propellant is spent. In space, things are a little different. You have to think about that any correction you make is expressed in terms of propellant. There is no preferred direction in terms of acceleration, but any kind of acceleration or deceleration is calculated, because actually is in terms of propellant. So the less correction you can make with your own propellant, you can optimize the whole spacecraft life. And this is also the reason why a lot of missions in the past and in the present are very successful, because a lot of propellant was saved instead of spent, let's say, useless. So again, other insights from the mission, and one of them will be the final year, which will be, let's say, the climax of the whole mission, with the focus on orbiting Ganymede for in-depth study. Well, what you can see here, if you're looking at the video, is infrared image thanks to NASA of Ganymede, which is again a moon of Jupiter. And we still very little know about the moons of Jupiter. We know that they are icy, but we don't have much more details in this sense. So as said, also from the moon, the name of the mission, which is Jupiter Icy Moon Explorer JUICE, that's the main scope of the mission itself. So again, the mission aims to investigate potential surface oceans on these moons, or maybe subsurface oceans. Indeed, physics is the same on the moons than here on Earth, but since pressure and temperature are kind of different, different phenomena can be expressed on these celestial bodies that we still don't know. And so, thanks to JUICE, a lot of interesting things will be revealed to humanity. And I want to underline a key player in this mission, which is Airbus Space and Defense, together with the European Space Agency. Well, Airbus, with its Space and Defense division, signed as prime contractor in 2015 and has led a consortium of more than 80 companies during the course of the project. The company was selected by the European Space Agency as the prime contractor for the design, development, and also production and testing of this new spacecraft with the revolutionary mission, which is, as said, exploring Jupiter's icy moon. So, thanks to this company, Airbus, now we have a fantastic spacecraft in space which will perform a flyby with respect to our planet tonight, between today and tomorrow. So, what I've said up to now seems very straightforward. I wouldn't say simple, but something that we have already experienced in the past. Well, when missions were designed, a lot of flybys were already performed, so nothing new. I would say that there are some challenges in this mission, and one of them is Jupiter's cold environment, which poses some precautions and also warnings in terms of energy collection. I would say that extreme temperature variation are a significant challenge for the spacecraft. Maybe you are thinking about, okay, but the spacecraft will be flying in space, so this won't affect very much the spacecraft. Well, this is not true, because you have to think about flybys as a process, as a maneuver which poses the spacecraft very close to the surface of the planet or the satellite or the celestial body more in general to which you are performing this maneuver with respect to. So if the temperature is very low, and with very low I mean something like 150 degrees below zero on the Celsius scale, so which is something like 120 in terms of degrees Kelvin, so absolute temperature, which is very low actually. So if your spacecraft is performing a maneuver in the range of this temperature, well, it will be affected by also this challenge. And you also have to think about this temperature in terms of scientific parameters if you have and if you want to observe the surface with some kind of instruments. So what's on board the spacecraft? Well, JUICE will is carrying now 10 scientific instruments for various observation, and the spacecraft also must minimize the electromagnetic emissions to ensure that accurate data are collected, and that's why engineers have developed a special technique to reduce the electromagnetic interference. What you see here is an image, which I have to thank ESA, the European Space Agency, for this, and also to acknowledge ATG Media Lab for supplying the image. You can find it for sure on the official website, but that's their image, and actually reports the spacecraft and the way it is quite clear how it is supplied with electrical power thanks to solar arrays. But as you can see, there are some antennas in different directions. They are dipole or multiple antennas, and most of them are connected to scientific instruments. So in particular, they have to capture the electromagnetic spectrum, particularly the electromagnetic and also the magnetic one, in order to quantify the variation in this term, in order to observe what's happening on the surface and also below the surface of the icy moons, which will be observed. So that's all for today. Save the date. Actually, we are already into it. August 19 and also August 20, so between today and tomorrow for the flyby. And let me know if you can see the spacecraft from the surface, and also let me know if you appreciated these updates. I would like to let you know that I've organized the whole thing in a hurry, so let me know if you appreciate this thing. Write down in the comments, subscribe, and also share this channel with your friends. Thanks for watching, see you in the next one.